Hey buddy, so basically in today's GFG POTD we have a problem rotate by 90 degree. So basically it is a medium level of problem, and as the problem given here, given a square matrix, the task is to rotate it by 90 degree in clockwise direction without using an extra space. So basically it is a medium level of problem, and in this particular problem we have a matrix and we need to rotate it by 90 degree, and we need to return those elements after rotating the matrix. That means, for example, here if we have a matrix here 1 2 3 4 5 6 7 8 9, so after rotating we got here 7 4 1 8 5 2 9 6 3. Similarly, if you're talking second example, so there's a matrix of n by n cross n matrix, which is like 1 2 3 4. So it will, after rotating 90 degree, the elements will be like 3 1 4 2. And in the third example, like here it is only one element, so after repeating or without repeating we got only one value, so 1 will be the output here. So here constant is given here, that means matrix of size must be like greater than equal to 1 and less than equal to 1000, and matrix must be greater than equal to 1 and less than or equal to 100. So as we can see here, like this problem is like really very important, as it is like asked in multiple companies also, like Paytm, Jovo, Morgan Stanley, Amazon, Microsoft, Samsung, Snapdeal and DigiSaw. So that problem is like really very much important, and it is like asked in most of the companies also, and it is like based, it is also, we can say it easy level problem, but the thing is that there is some logic which we have to work on. Like it is completely based on like matrix and data structures, and it is like asked in multiple interviews also in multiple companies also. So we need to solve this problem with an expected time complexity of order of n square, which is like common. If we are like solving any type of matrix problem, then it will like order of n square is the time complexity, and talking about auxiliary space, so it will be like 0 of O of n, big of O of 1. So before solving this problem, first of all we need to understand the approach. On the behalf of the first example, let's understand this problem here. So basically this is example 1 here, where we have an element like 1 2 3 4 5 6 7 8 9, which is a 3 by 3 matrix. Okay, and after rotating 90 degree, that means if this is the matrix, then after rotating 90 degree, our first row will become the last column. Okay, and our second row will become the second column, and our third row will become the first column. So this is the approach here. Our first row will become the last column of the new matrix, we can say that, and we need to solve this one with the same within the same space, so we don't have to change it. And our second row will become the second column, the third row will become the first column after rotating 90 degree. So the approach to solve this one is, first of all we have to here first of all we have to declare, let's say int m is equal to, that means the size of matrix, mat dot size, and then after that we need to define int n is equal to, that means the first matrix of 0 dot size, which basically defines the first row. Okay, and then after that we need to traverse inside the matrix. Okay, so here for int I is equal to 0, I is less than matrix size, whatever is the size of matrix, we need to traverse till the end. Okay, if it will like 3, if the matrix is size 3, then we need to traverse till 2 cross 2 matrix, so I plus plus. Similarly inside that we have to also traverse it for column also, so int j is equal to 0, I is basically traversing for row and j is basically traversing for column, and j is less than mat dot size, and then j plus plus. Now while traversing through both rows and column, that means by traversing through like in this way, now we need to place all those elements by rotating 90 degree. So for that, here we have to also create a new vector. Here we have to create a vector which is basically to store the elements after 90 degree rotation. So vector of int type, and I am defining my vector as answer, and then after that I need to define their sizes. let's say m here, and then after that I have to define vector of int of size n, and which I have to initialize it with 0. Now once we have created the vector here, now we need to here we have to declare another variable which is basically used to store the present value, that means I and j value. Let's say if we are traversing through 1 to 3, or if we are traversing through this row, then whatever the value we are actually getting first, we need to store it inside the, let's say, int value. Here you have to define a variable int value, or let's say store here. If we have like declared a variable store, then here we to store our matrix, that means whatever we actually getting, matrix of I and matrix of j. Once we have like stored all those things, now we need to uh, store it in such a way like it will be rotated by 90 degree. So for that, what we can do here we have to int store is equal to matrix of I and j. Then after that, here we have to do matrix of I and j, and then after that here we have declared a answer variable, and then here we have making a store variable. Then what we have to do now, here we have to create matrix of j. Okay, now here we have to like rotate all those values, that means by 90 degrees. So first of all we have to take j value, that means whatever the whatever is our row, we need to convert it into column. Okay, so first of all we have taken matrix of j, and then after it we have to take n minus 1 minus I for getting the row value. Okay, and we need to store it inside the store value. Okay, and then after that we need to say that and then after that we need to simply not matrix here, we have to declare answer, that means here we have to put it into the vector answer of j, and n minus 1 minus I is equal to store whatever we have declared here. Okay, then after that here we have to say that means matrix is equal to answer. Let's try to compile and run. And so n was not declared. Vector and answer type, and then after that we have defined the sizes, that means okay, so here we have like initialized first, then after that the size of the matrix, and then after that we have taken here, and now again let's try to compile and run. So yeah, its compilation is completed. Let's try to submit it. So it's submitted. So yeah, that's all for today. Thanks for watching.